Okay, so I'm gonna continue to go through the example so you understand better about this lesson. Okay, so let's see example 1. State whether the function graph in figure 2.2a has a limit at a given x value and explain why or why not. Is there a limit? Give its value. X equals 1, x equals 2, and x equals 3. Okay, so this one is still easy. You don't need to use the epsilon and delta, but just look at the graph. It's very obvious that when x is approaching 1, then the value of y is approaching 2, right? At the same direction, for the both direction, which is from the left and from the right. So we will say that when x equals 1, the limit exists, which is equals to 2. Even though the exact value of the function when x equals 1 doesn't exist. Yeah. Now when x equals 2, what happened there is still the same. When x approaching 2, the fx is approaching 5 from both direction. Yeah. So for b, for x equals 2, the limit also exists, which is 5. Now for the third example, when x equals 3, because they are approaching the different number, from the left is approaching 10 and from the right is approaching 8. So actually, because they approach different value, they approach different value of fx, so the limit as x approaches 3 of fx doesn't exist. So that's example 1. And then example 2. Figure 2.2b shows the graph of function f for which f of 2 is undefined. What number does limit x approaches to fx equal? Write the definition of this limit using proper limit terminology. So you don't need to do that. You just need to determine what's the limit. And if you see the graph, then actually as x approaches 2, the function is approaching 4. Yeah, again, when f equals 2, then the function doesn't exist. But the limit as x is approaches 2, then the fx is 4. Okay, now let's get into the second one, the b. If the epsilon is 0.6, okay, so and then we have the value of the limit, which is the value of the limit is berapa? Just now 4 ya. So actually if this is 4, then actually we are going to make two lines, which is the distance is 0.6 from 4, right? So this will be 4.6 and this will be 3.4. Okay, and I will try to draw the function to you so it's not confusing. So it's going to be this. Okay, and then when if the fx is 3.4, then wait, before that let me draw the c first. The c is actually equal to 2, yeah. Okay. When the fx is 3.4, if we try to find the value of x here, then actually the value of x is given by your book is 1.6. Okay, and then when the y is 4.6, then the x is actually 2.8, around 2.8. Okay, so the delta for this one and the delta for this one in this case is different, which is okay. So the delta 1 will be equal to 2 minus 1.6, which is 0.4, and the delta 2 is equal to 2.8 minus 2, which is 0.8. Okay, so now which delta should we choose to keep the limit valid. Yeah. So the one that we need to choose is the one that is smaller, which is this one, 0.4. Yeah. Why 0.4? Because if we make it 0.8, if we pick the larger one, then actually we will have it here, right? Which is it's 1.2. And actually, let's say that it meets here. And this is the value of y. So actually the epsilon is not in the epsilon is greater than 0.6, right? Which is not allowed because the epsilon is kept, which is 0.6, within 0.6. That's why we need to keep the smaller one, the 0.4. Yeah. Okay. So that's example 2. And then I will do example 3. Okay. Of example 3, the equation is given, which is fx is equal to x minus 3 power of 1 over 3 plus 2. And then it says that as x approaches 3, the fx is approaching 2. And actually f of 3 is equal to 2. So in this case, the exact value does exist. Okay. Now, A. Find graphically the largest value of delta for which the fx is within epsilon 0.8 unit of 2 whenever x is kept within delta units of 3. So I'll skip the graphically part. I will show you how to do it algebraically, okay? Now to do it algebraically, again, it's like the previous example. The epsilon is equal to 0.8. It means that the y1 is equal to 1.2 and the y2 is equal to 2.8, which is 0.8. The distance is 0.8 going up from 2 and 0.8 going down from 2. Okay. And then of course we try to find the value of x when the y is equal to 1.2 and 1.8. Let's go. So if 1.2 is equal to x minus 3 power of 1 over 3 plus 2, if we subtract by 2 both sides, negative 0.8 equals x minus 3 power of 1 power of 3, and then we keep both sides, which is, if we keep both sides, then the result will be negative 0.8 cubed, which is negative 0.512 equals to x minus 3, and the x equals to 2.488. Okay, and on the other side, when y equals to 2.8 equals x minus 3 power of 1 cube plus 2. Okay, and then divide, subtract by 2 both sides. We have 0.8 x minus 3 1 over 3, and then we cube both sides. 0.512 equals x minus 3, and x equals 3.512. So this is x1 and this is x2. From x1, we know that the delta is actually equal to c minus x1, which is 3 minus, in absolute value, 3 minus 2.488. So it's equal to 0.512. And also the same in this case, the delta is equal to c minus x2, which is 3 minus 3.512. And equal to 0.512. Well, apparently it's the same. So the delta in this case is 0.512. Okay. And then the Yeah, I think that's it for today. I hope you understand about this lesson. Thank you.